And we're going to start section 1.5 about transforming functions. Okay, so we're going to take a function and we're going to shift it left or right or up or down. We're going to reflect it, and we're going to stretch it vertically or horizontally. Okay, we're going to do all those things, but we're going to start with the easy ones first, which are vertical and horizontal shifts. Okay, so let's start with the easiest, vertical shifts. And one thing I want to say, I've noticed that the CP&M curriculum does an excellent job of preparing you to think about transformations of functions. So hopefully this will seem like something you've seen before and that makes sense to you, but it can be challenging. All right, so first let's talk about vertical shifts. So if you have a function and we have a new function, g of x, where we're just adding a constant, right? And that constant could be positive or negative. It's a vertical shift of the function f of x. So all the output values change by k units. And if k is positive, it shifts up. And if k is negative, it shifts down. So if we were looking at a graph, maybe does this blue graph look familiar to you? It's one of our toolkit functions. It's the cube root of x. Okay, so if we have the graph of f of x that looks like this, and we add 1 to it, it just shifts the whole thing up by 1 unit, right? So the origin, where it usually crosses at the origin, it goes up to 0, 1. So the whole graph just shifts up or down by whatever the constant is that you add. So here's kind of a word problem and application. All right, so to regulate temperature in a green building, airflow vents near the roof open and close throughout the day. And this figure shows the area of open vents. So it looks like right at 8 o'clock, the vents start opening. They stay open until, looks like about maybe 6 p.m., and then they start closing. During the summer, the facilities manager decides to try to better regulate temperature by increasing the amount of open vents by 20 square feet throughout the day and night. Sketch a graph. So they're just going to increase, for every hour of the day, they're going to increase the number of vents open by 20 square feet. So really, they're just adding 20 to everything. They're shifting the whole graph up. So if we look at the graph, it's going to look like that. And our new function is just going to be the old function plus 20, plus a constant, right? So the red graph is the old graph just shifted up. Nothing else has changed. All right, so what if we have a table and we want to shift that vertically? So we had our original function f of x, and we subtract 3, right? We have a new function g of x. It's our original function minus 3. Well, it's going to be the output values. The input values are going to stay the same, right? It's going to be the output values that decrease by 3. So we can look at that here. We have our original input values. Here are original f of x values. And the output values for g of x are just going to decrease by 3. So 1 minus 3 is negative 2. 3 minus 3 is 0, and so forth, right? So just the output values just shift down by 3. Okay, so let's think about horizontal shifts. So horizontal means left or right, right? So here, for a horizontal shift, the new function is going to look like this, right? Before, like here, the minus 3 was on the outside. It was f of x minus 3, right? But for a horizontal shift, we have x minus h inside was getting input into our original function, okay? So h is a constant, and it's a horizontal shift if we have something like this, x minus h. So it could be x plus 3 or x minus 4. If h is positive, the graph will shift right, and if it's negative, it will shift left, okay? But there's that minus sign there, so we have to, it's a little bit tricky. Let's look at this one first. So here we still have our cube root of x function, but it is shifting to the left, right? The new function is this red dotted line, right? It shifted to the left by 1. The origin went over to negative 1, 0. And so we shifted to the left by 1. So our h value is negative 1. So we have x minus negative 1, which becomes x plus 1. So that can be a little bit tricky. If your function looks like f of x plus 1, the function is shifted to the left by 1. If it's x minus 1, it's shifted to the right by 1. So it's a little bit counterintuitive, at least for me. In my mind, plus means it's going to the right. But in this case, it's opposite, right? because it's x minus h. Okay, so we're back to our building facilities manager, and he decides that the original venting plan starts too late, and he wants to begin the whole thing 2 hours earlier. Maybe they shift their office hours or something. So he wants to shift the whole thing 2 hours earlier. So the new function, the whole graph just gets shifted to the left, right? And the function would be f, I guess the original one was v. So the new function was be v of x plus 2, right? Because we're shifting to the left by 2. All right, here's another toolkit function. This is telling us it's a transformation of the toolkit function f of x equals x squared, right? Which is just a parabola, and the vertex is at the origin. So this looks like it's been transformed by being shifted to the right by 2. So why don't you just take a minute and write down what you think this new function, g of x, what its equation would be, right? Our original equation was x squared, and it got shifted to the right by 2. So it's going to be f of x minus 2, right? It's shifted to the right by 2. Our h value is 2, so it's x minus h, f of x minus 2. Okay, what if we started with our toolkit function absolute value of x? Sketch a graph of a combination of vertical and horizontal shifts. Okay, so let's look at this. Before we look at the graph, let's see, we have a minus 3 tacked on the end. That's going to be a vertical shift 3 units down. And here we have f of x plus 1, which means the graph is going to be shifted to the left by 1. So with vertical and horizontal shifts, the order doesn't matter. You can just choose one. So let's see, our blue graph is our original absolute value of x. Here, the red graph is shifting the graph to the left by 1, right? And then the green graph does the vertical shift down by 3, right? So there's our new function. The green graph would be this blue graph shifted over and down. Okay, here we have the toolkit square root function, and it has been shifted. It looks like usually it begins at the origin, right? So it looks like it's been shifted to the right by 1 and up by 2. So take a minute, pause it, and write down what you think this function, the equation of this function will be. And there we go. It's been shifted up by 2, so we add a plus 2 on the end, and it's been shifted to the right by 1. So we have a minus 1 inside the original function. Okay. And that's the end of thinking about vertical and horizontal shifts. Let me know if you have any questions.